So you should have completed the Fast Start activity. This is Unit 1, Module 2, Lesson 2, Casting. After this lesson, there will be a summative quiz after this lesson is completed. So you need to make sure we do that face-to-face. It has to be scheduled if you're in the blended class. If you're already face-to-face, we'll be doing that face-to-face together. Do not start a quiz that is summative without being in a room with me. So even if you happen to find it open, don't take it, because you're only allowed to take it one time. And if you take it and you're not with me when you take it, it's automatically a 0. Okay? So you need to make sure you're only taking summative quizzes when you're with me. There is also a summative programming assignment that will be coming up after this lesson. So we have 2 summative assignments coming up. One's a quiz that will be in class. One is a programming assignment. You will get some class time to work on the programming assignment, but not a huge amount of class time. So be prepared. Think about your schedule, that you're going to need some time devoted at the end of this week to work on that summative assignment. I'm tentatively planning that this lesson should take you 2 sessions, and then you'll have the summative quiz. If we need more time than that, we'll work it out. So to dive right in, casting. We kind of sort of fake casted the other day. We multiplied by 1.0 to take a double, or to take something that wasn't a double and force it to be a double. So, for example, if we had 5 divided by 6, that's an int divided by an int, the result ends up being 0, because that's integer division. It truncates all decimals. We don't want it to truncate the decimals always. Sometimes we actually want the decimal result of 5 divided by 6. Our solution last couple sessions to work around that was to multiply by 1.0. That's not a great solution, and it's limited to just doubles. That's the only thing we can fix with that. There are other circumstances when you need to fit something bigger into a smaller box. So, for example, we might want to put a character inside of an int, or an int inside of a character. Now, that sounds weird when we say it that way, but you can do that. So we have to be able to tell Java what exactly we want to do. So let's take a look at this code here. This is the very beginning. This is pretty much the situation I just described. We have int equals x, int x equals 15, and then we have a double called half that is assigned x divided by 2. The result of that, though, is not the decimal division we expect. We're not going to get 7.5. The result of that is integer division. It truncates it, even though it's storing it into a double. It still is inactive memory as an int. The result is 7.0 because it did store it in a double. So it did promote the 7 to a 7.0, but it didn't really do the math the way we wanted it to. It truncated the decimal. So to fix that, we're going to do what's called a numeric cast. And we can cast with other types of things as well. The way we did it before is we did 1.0 times x divided by 2. And that gives us a 7.5, but that's so clunky. And it's not really an elegant way of doing things. In computer science, we always look for a more elegant way. So the more elegant way is to do this. Let's look very closely at the code. Make it bigger for you. Double, half, equals. Then we have this declaration in parentheses that tells Java active memory needs to be a double. Now when it does x divided by 2, active memory is set up as a double, and it's not going to do integer division. It's going to do decimal division and give us 7.5. This is a numeric cast. So rather than doing that 1.0 times x divided by 2, this is more, I guess, elegant. It explains the answer better. It tells what you're actually doing when you're looking at the code. You're turning something that is an int into a double. So you should be trying this in your startup file. Make sure it works, so that way you can see it. I believe that sometimes typing the code itself transfers in the memory. So take a second, pause that, and type that in and run it. So when you run it, you do get the 7.5. So when we're changing one type to another, essentially it's all about memory size. Java is going to run the most efficient version of itself as it can. So it's going to put things in the smallest box that it's possible. But you, being the logical thinker, know the future for your program and know what you want your program to do. Java can't predict the future. It can't see more than one line at a time. You can. You have a plan. You know what's going to go on. So as the programmer, you might have other ideas. So Java will let you do this without a problem. Java n equals 18. No extra issues, because it's taking an int and putting it inside of a double. That's the most efficient use of memory. However, these widening conversions are all done automatic, but the narrowing conversions are not. Narrowing conversions, when you're putting something bigger into a smaller box, are not done automatically. Something has to prompt that to happen. So an int into a double, that's fine. Take this little int, stick it in the double box, but we know we get the 0.0 because it's now a double. It officially becomes a double. When we change one type to another, this process is called casting. We can take a bigger data type to a smaller data type. And Java has special commands for these. This is to prevent us from losing data by accident. You know, it'd be unfortunate if you're doing 30 calculations to get a final answer and you have a couple issues in there with your variable assignments. If Java automatically decided to run the program by truncating decimals and never gave you the option to figure that out, that could be problematic. So we're going to go through these, and I want you to look to see if which one is legal, which one is not. So what I want you to do this is take a look at it, decide if it's legal or not, then pause the video before you see the answer. So pause now. It'll go one at a time, and then just hit play, pause, play, pause. So the first one is legal. Take a look at the second one. Looking at the second one is assigning a double to an int, so not legal. Let's take a look at the third one. So we take a look at the third one, and we see that because of the 0.0, this is not a legal statement. Technically, it's still a double. And then the last one, so looking at the last one, answer, yes, that's fine. When you put the 18, it will automatically be promoted to a double without an issue. So the programmer must cast a double to an int. You use this symbol. If you have to cast a double into an int, you use this symbol. You might ask yourself, why would a programmer want to do that? Why not use the double? It just seems like it's better, right? Sometimes you want to truncate. Sometimes you only want the whole number value. You don't want the decimal value. So let's think of a real example when you might want to do that. Pause the video, see if you can come up with an example. Suppose you have a ferry boat, and the ferry boat has the ability to hold a certain number of cars, right? But it also has the ability to hold a maximum weight. Your choice is go by the numbers of cars or go by the maximum weight. Some ferry boat driver, it's a Monday morning, decides to go by the maximum weight. It's just looking at the numbers and says, oh, we have another 50 pounds that we could fit. So let's just drive the next car on. There's a problem with that because the car is a heck of a lot more than 50 pounds. You have to throw that away, even though you could technically round, if you say, even if it was half the weight of a car, even if it was 3/4 of the weight of a car. Round up. No. You can't round up because if you go over that maximum weight, that little ferry boat may not make it across the river. You might have an issue as you're trying to head across the river because you're over the maximum weight. So there are things where you just have to cut off that decimal. You can't go beyond that. The other example was the class. We're dividing a class up into groups of people, and it so happens that we end up with an 0.66 repeating version in a group. We can't start cutting people into 2/3. That doesn't work. Well, it does if you're in a magic show, but doesn't work for school. So programmers, when they take a conversion and go smaller, like a double to an int, this is called a narrowing conversion. Java will not do this all by itself. Java will either throw an error at the compiler time, or you just will have to reprogram this and cast it. It won't let you do it. So to take 7.5 cars on this ferry boat won't work. We can only take 7 cars on a ferry boat, even though technically the number would be rounded up. So here's an example where we take a decimal, 3.756, and we want to cast it as an int and store it inside of x. Pause the video, think about for a minute what actually gets stored. So if we were to take this and run the code, we would take a casting and make it a 3 that gets stored in x. However, these two don't have to match. If this was a double, this casted int would be a 3. But then, since we're storing it in a double, it would be 3.0. So the casting does not necessarily have to match the type, as long as you're going from something smaller into something bigger. Java will do that just fine. So yeah, we can mess around with what we're doing. You have lots of options. Java will always let you fail as well as you can. It really doesn't limit you in many respects. So it's not rounded. We just get the 3. It's truncated. So there's an exit ticket that I'm going to have you guys go through. And then there's a practice assignment that I'm going to have you guys go through. I want you to work on those assignments, and we're going to walk around and check to see how you are. If you have questions on the video, you can send me an email.